All right, what is up? Good morning. Hello to Liz over in the Discord chat. Nice to see you this morning. Let's put over here. My head is kind of clipping. Maybe that's just the green screen being weird with the light. Right. All right, there we go. So welcome, first of all, for anyone who is new. If you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I stream around this time each week, 10 a.m. Central Time on Tuesdays here on the Adafruit channel, typically working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website here, circuitpython.org. This is basically a version of Python that lets you run Python code on tiny computers that are called microcontrollers. Typically, the way it works, you plug it into your computer with a USB cable. It shows up like a thumb drive. You can open a Python code file that's on that thumb drive. You can use any text editor or code editor that you want. When you edit the code inside there and save it, the microcontroller will reset and execute the new code for you. And inside your code, you can put stuff to interface with other hardware peripherals. So things like LEDs, buttons, buzzers, speakers, sensors, all kinds of stuff. And you can kind of use your Python code to make them do interesting things. As always, thank you to Adafruit. Adafruit makes CircuitPython possible by paying a team of folks, including myself, to work on the project. If you would like to help support CircuitPython as well as the other open source software that they pay people to work on, one of the easiest ways to do it is by purchasing hardware from them at their website, adafruit.com. You can get microcontrollers. You can also get those peripherals, the sensors, the lights, the beepers, the buttons, all kinds of other things that you can hook up to build fun and interesting stuff with. I am jumping in today to TinyUSB. I have this for right now. I'm jumping in today into TinyUSB looking at audio stuff. So I'm not looking directly at CircuitPython stuff today, but I do sort of have my eye on, in the more medium to longer term, implementing this into CircuitPython. So this is kind of like the beginning stages, the seed of something that could eventually find its way into CircuitPython. But for today, it is inside TinyUSB. I'm looking at the audio test example that's in here. For anyone that doesn't know, TinyUSB is a library that implements lots and lots of different USB input and output drivers, protocols. I'm not sure the exact right terminology, but basically this is kind of like an Arduino library that is a dual sort of USB device. It can handle USB host stuff. It can handle USB client or device. I think it is device, right? It can handle all sorts of different protocols. So like your HIDs and your mass storage and your MIDI and all this kind of stuff that CircuitPython can do. CircuitPython actually just uses TinyUSB under the hood to do all of that stuff. So one of the other things that it can do, though, is in the examples device audio, it can act as it can actually act as both audio input and audio output, and this is over USB. So again, you know, we're a couple layers deep here, but it's the library that would run on the microcontroller, and it would allow that microcontroller to then be plugged into a PC, a computer, over USB, and it would make it so the PC will see that microcontroller as either like a pair of speakers, USB speakers, or alternatively as a sound input, like a USB microphone. And the sound input, the USB microphone, that is what I am more interested in, because what I want to do ultimately is get the microcontroller to play sounds into the PC, so to speak. I want it to be able to play a tone that the PC can then capture and record, or capture and send somewhere, capture and do whatever it wants with ultimately. And then to peel back the curtain ever so slightly more, what was it? Paddle, I think, right? Morse code paddle. So this is where I'm headed with this. Next project is going to be a Morse code paddle hookup, essentially. So like the goal is to get one of these sort of nicer Morse code paddles that allow you to tap in your dots and your dashes, and then show how to hook that up to a microcontroller into modern, PC equipment and such to get your Morse code audio into there. But before I can get this thing hooked up and do all of the fun stuff, I need to be able to get the tone to come out of the microcontroller and be controllable. So that's where I'm at right now. I do actually have this running. So audio test here does exactly what I was just talking about. It makes the microcontroller sort of appear as a microphone. Yeah, looking into audio, TinyUSB. What's up over on YouTube? Neil Saboda? Yeah, I think so. Yes, that's what we are looking into today, is TinyUSB audio. So I do have this. What is up, Le Crotal? Hello World. Over on YouTube as well. So this one does exactly what we're talking about. It shows up like a microphone. In this case, it just plays a tone, and I actually changed it. It was originally 440, 560 is what I changed it to, just to make sure that it's actually, doing something different. What I would like to do next, though, is make it a beeping tone. So if I come over here, and if I can delete all of this stuff, which I actually find kind of difficult sometimes. I don't really understand the exact right order of operations to be able to successfully delete stuff in here. So I can actually have this plugged in already. So I have on my desk here a macro pad. I still don't have the top-down camera situation resolved, so I can't show it to you, but honestly, there's nothing to see. It's not showing anything on the screen or doing anything with the lights. It is just a macro pad RP2040. I can show you a picture of it right here. Plugged into my computer. It's not doing anything near as interesting as this. It's all just off and dark and sitting there like a thing plugged in. But what it is doing is showing up as a microphone. I can start recording here in Audacity. I've set the input to it already, and you can see there it's producing this, in this case, 560 hertz tone. I don't think the audio is probably coming through. I could give you a sort of a quiet taste of it there, but there's, again, not that much interesting going on. It's just making the tone right now. But it is working. And then next, what I want to be able to do for Morse code, obviously, we need to be offs and ons. So I'd like to make this beep off and on some. And I think the way that we do that is in the code here. Let's see, one frame is received. We assume that the audio data is read from a buffer. Yeah. So one thing is there's no loop in here. What is up, Toddbot? Over on the Discord. Nice to see you, my friend. I have the, yeah, okay. So does this, how does this loop? Because presumably this is something that is going to run continuously. This is looping to sample count, which is the size of the buffer, which I think is not huge. Maybe 1 second. I'm not really sure how much it's buffering. It does all of this loop and then it writes. So does this get set up elsewhere? Ah, okay, here we go. Inside of main. Okay, yeah. So this is our infinite loop. and it's basically calling each one of these. Okay, I guess I lied a little bit. It's blinking the LED. Actually, know that it is blinking the LED, and I did not know that because it's on the it's on the far side of the device where I can't really see it. Okay. So I think this would be sort of like make the USB thing do its thing, blink the LED if it's time, and then generate the audio, which will get saved to the buffer. This will be taking that same buffer, presumably, and writing it out. Ooh, this one doesn't exist. Must be imported or something, but there's no... Yeah, I guess that one's imported or something. Okay. So this is getting called over and over. Let's look inside of LED blink. It should be having some kind of on-off cycle. Yeah. Okay, I want this, but for the beeping. So, and again, this is getting called over and over, so these get reset every time. Start time is 0, LED state is false. And then we check the time, and if not enough time has passed, then we just skip out, we just return. If enough time has passed, we go on, we don't actually reset this, but we add to it the interval. We update the state to false. Then we toggle the state. I assume, although minusing a Boolean. This feels like a very awkward way to toggle a Boolean. I don't write C very much though, so maybe it's standard. I do not quite understand this though, because this is going to always write false, isn't it? So this is creating the state here, and then this is updating the state. Interesting. Well, Huh. Yeah, I don't quite follow that. Unless I'm misunderstanding and this is not gonna like recreate a new variable state, or at the very least reset its value to false, which it certainly seems like it's gonna do both to my eye, but at the very least reset its value, even if it's not creating it. Then we get to here, we set this, we write the LED, we update this presumably for next time, but by the time next time happens, this would get reset. I don't know exactly how to output log statements or anything either. LED state is static, so it remembers the previous value. Okay. Interesting. And that is just a way that static variables behave in C, or? Okay. Static makes it jump the context. Sorry, I don't understand at all what you say, but I'm French, but maybe the AI will help you for any decisions. Static variables have reserved memory to store their value between function calls. Okay. Interesting. I did not know that. Huh. Okay. So then that is going to update each time. Yeah, so anytime that enough time has passed, it will get to here and it will toggle. And then the next time this gets called, it will be true instead of false. Okay. So we should be able to do something similar for audio. Where was main? Then audio task. Oops, gosh. Why can I control click one way? We actually already have a start millisecond, so we don't really need that part. Let's call that tone state. It actually already has this as well. But that must be driving a much smaller timescale than I'm thinking of. I think we want an outer thing here. Or I think we want another thing that will let us bounce early. Toggle tone every interval. Blink interval should be, I don't know, half a second or something. I'm not sure where it came from. Blink mounted, blink not mounted, suspended. Oh, it has different rates for... Interesting. Let's just use 500. Has different, the LED blinking actually has different rates as part of the status of the USB stack. In C, static is function local global, so the initialization happens once. Nice. Yeah, thank you both for the tip there. That is my learn something new every day for C, for sure. All right, so toggle this tone, return early. Otherwise, we add to it this. And then we go on and do all the rest of the normal stuff. And then we toggle the state at the end of the normal stuff? Maybe. Sure, that's gonna work. We do want the tone state. Late to the party. What's up, Relic SE? But USB audio would support would be super stinking cool. Yeah, for sure. I agree. So I was looking around a little bit. So my immediate aim, I just replace. Okay, yeah, those are both state. My immediate aim is likely going to end up being Arduino code using this TinyUSB stack, but I did already start the exploration into the CircuitPython code. Let's try to build this here. I did already start looking into the CircuitPython code to figure out what kind of effort it would be to add USB audio there as well. At least for microphone, what I'm doing here. So microcontroller outputting audio to the PC. And I think that it might actually not be super de-duper hard because there's actually already a USB video module, which it turns out I think is structured similar to what we would need for audio. This is what a little bit of conversation with Claude led me to believe, at the very least. Let's go here. And I don't actually know the full, like, what is required, but I think if I click this, hopefully it will re-show back up. Interesting. So that's definitely broken now. Does not record. Well, it does not. Yeah, I don't know. It's like it's not sending data, I think. Almost. What if we started with true? I was learning new things about the core. Had no idea USB video. Yeah, I remember vaguely. I think maybe Jeff worked on that. I sort of remember vaguely when it was added, but I don't think I ever actually messed with it. I should though, because it would be kind of cool. I'm just gonna keep doing rescan because earlier this was breaking when I was not doing that. I don't think our logic is gonna be correct here, basically. I wonder, we probably can't just, well, but this is just returning. Cat has decided that now is the time to run around like crazy. I think we probably cannot just return here, though. I think we need to probably be returning silence, not doing anything. Because like this is coming down, generating samples for the tone, and then ultimately writing those samples into the buffer. I think instead of returning early, what we need to be doing is filling that buffer with silence. I guess is zeros? Okay. Let's make a new one of these. Call this last tone toggle. Because this is kind of how my brain works. It looks like this is giving us the time. So how about we actually could we just keep this here? But not return, and instead toggle whenever this hits, and also update. Would it be greater than 500? Yeah, I think we want to flop this. And then I think we want to update this. Oh, I probably was wrecking that before by changing start MS. Yeah, I think we probably should not have ever been trying to use the same variable to track the toggling of the tone, because this is also being used to track the timing of something else. And I bet that's why we didn't actually get any audio. So this should toggle tone state for us. And then in here, if we can... say if by tone state was tone state. I don't know, do you have to do... That's true, then do all of the stuff we're already doing. Else, if that's false, we basically want to just get all zeros. So this is doing what? This is basically setting count. So could we just reuse all of this, but set this to 0 instead? Nice. I won't make you endure that for too long, but it's working. Okay. So now we can turn the tone on and off. But really what I want is ultimately like manual control of the tone. Like with a button, really. So I'm on a macro pad, so I think the next step is tone playing whenever I press a button, tone not playing whenever I am not pressing the button. I don't even know basic button press in Arduino. Arduino button press example. What is this? It's text. Digital read? Code not here. Getting too fancy for its own good. Like, this code is just text. You can just put text on pages. I don't know. It doesn't need this whole fancy dynamic loading box thing or whatever. Oh, this is actually a really nice page. I always forget this, like which ones are connected. I'm always sitting there with the multimeter trying to like hold both probes and press a button at the same time, figure out. The code is Python. Looks C++. Sorry, I'm a noob. The code is C. This code is C, I think. Arduino C. But I am mostly a Python developer. So while it is on my screen and I'm the one writing it, I could also be technically wrong. It may be something slightly different. But okay. This is what we need pretty much. So I do need the pin. pins on the macro pad. I should say, if anyone is interested in replicating this, I did have to add board definition to TinyUSB for the macro pad, so if somebody is like actually trying to do this on a macro pad specifically the same way I am, you'll need the board definition files. I could give them to you, but let me know. Get this. Where does this go? It's in variants RP 2040. I never remember which like variants or boards or devices, which repo uses which name for the folder that holds the pin. Oh, this doesn't have any of the buttons anyway. All right. Should have came here first. What are we looking at here? We have GPIO. I think I want the bottom row just because that's most convenient. So like maybe key 10, which would be GPIO 10. Oh, please. Okay, I was like, please tell me I didn't leave the thing there. All right, do some more setup here. So we're gonna get a button pin. We want 10. We will set these things. I'm gonna call this button state and button state, since we have the tone state and we have the LED state. So we have they have names. Although the tone state might go away with this, but that's fine. So we do need to set pin mode. We should have a... Actually, one thing is we don't have a setup, actually. So it's maybe not technically Arduino, because we're not using setup and loop. But we are using TinyUSB, which I think is an Arduino library, or works on Arduino. This is probably not going to work, is it? This seems like it's not going to work. In fact, we may be literally running into the fact that it's not Arduino. Huh, yeah, so I don't even know how I would get that stuff. Okay. We are going to copy this back over to here. And ask the friendly bot friend of helping us write programs. But we are going to start a new one. Don't really need the rest of that session. But in that case, we do need to know the directory. So examples, device, audio test. Say working on examples, audio test. Oh, device, I forgot device. Like, that's not quite right. My guess is we either need to import something or we need to do it an entirely different way from Arduino. And presumably there will be a different, like, API for it. Looking for button pins, but it's not going to find them. It might, well, I don't know if it's going to go back to CircuitPython, actually. The previous session, we went into CircuitPython a little bit, so it would, in that one, it would have gone and looked at the CircuitPython board def. Yep. Bare metal. Two ways. Option one, use board button read. TinyUSB exposes that. One button per board. Okay, yeah, no, and boot cell in this case is on the knob. The rotary encoder can push in, but I don't want to do that. Probably need to use Pico SDK. Nice. 2. What you'll actually want, in fact. Button 10, it's one of the 12 mechanical keys. True. Okay. A little annoying to copy from, but I think it's okay because it's a couple of lines only, hopefully. Here's one way. Alright, I gotta do... Wait, no, wait. The GPIO thing? Slightly different. Buttons. Standard lib. That's like a whole... Interesting. Okay. I'm gonna try it this way. But I think this we have, or if not, we can... Right now it's an int, which we don't want, I guess. We do want to define, apparently. I'm gonna keep it here, though. Side main. And then reading it. We didn't actually put this code yet. And then I think we have this already. So last button, that's basically just button state. And truthfully, I don't need to debounce it because what I want is tone on when button pressed and tone off when button released. It's a bit more complicated than I thought. See, the functions are setter, put and get, and then bot has your back, yeah. Yeah. I would say almost like probably one of my favorite things is being able to dive much farther into stuff than I would be able to without. The fundamentals of this programming language I get and stuff, but actually mucking about in it, I don't have the ability to do without some kind of specific prodding like that. So it's really nice to be able to dive into stuff that I would not. Maybe not that I wouldn't be able to, but stuff that would take me like a day just to wrap my head around like how to get the build working and get the environment set up and stuff. I can just get way faster and then start changing the code, and then that's where I can really take off and get stuff done. Okay, I think we don't really, technically I don't think we're really going to need both of these. And then one question is though, where would we do this? I guess we could just keep it in the audio task. So we don't really need another task to check the button. And instead what we can do is honestly just swap in the audio task the Boolean, so we have tone state right here. I think we could actually just comment this stuff out. And then instead of tone state, just read the button, which would be GPIO get. Or I suppose what we could do is update tone state to be that, and then we don't have to change the code there. So let's do that actually. Yeah, tone state equals GPIO get button pen. So then that'll be on when that's pressed. Oh, we might need to not that though, actually. False equals pressed. So let's go not, and then yeah, we're not debouncing, so we don't need any of that stuff, I think. Let's try this. I think I did not delete something. Did I not delete? We don't need that. In fact, we ended up not needing any of these because we already had tone state, and I just used tone state and read the button value into it. Here, because I just bought an AU Raspberry Pi, the Pi 500. Probably just bought a Raspberry Pi 500, the fabulous CyberDeck from Adafruit's amazing, fantastic world. Thanks. Yeah, awesome. I am definitely a big fan of the Raspberry Pis. I don't have one of the 500 or 400. I don't have one of the built-in ones, but they do definitely look super cool. But yeah. Let's copy that and go back to here. Delete this. See, here's where I selected all and I'm pressing delete and nothing's happening. So I don't get like, and then if I deselect, it's like you didn't select anything, and I'm like, so then I think if I right click and then get out of the menu and then select and then delete, it works. Okay, here we go. So recording is quiet. Nice. Cool. Okay. I don't actually know any Morse code yet, except for SOS. And I don't actually know SOS, just I know the pattern that will lead to it eventually. Okay. Yeah. This is pretty much, this is what we want. Okay. About 15 minutes. I'm honest, I wasn't sure I would make it this far. We can... What else could we do here? What else do we need? One thing I kind of wanted to do, I don't think I'll do it right now, but it sounds kind of fun. I guess maybe we could stick Claude on it and see if it just knocks it out. It would be kind of, it doesn't really tie back to the Morse code thing, but it would be kind of fun to set up 10 of the buttons on the macro pad and make a dial tone thing. Have the LED reflect. Oh, that's a good idea. Yeah, we should do that. Yeah. That's definitely duplicating out to 10 would be good. Fast Cloud, I can imagine it will figure out a way to loop it with a list or something. Which I could probably do again given enough time, but C is not my bread and butter usually. Yes, let's do the LED. So instead of, in fact, why don't we just turn off the LED blinking task there. And instead write the tone state also. So then it should be LED on whenever the button is down. And in fact, we could put this just right here, I think. This is a super quick build. And I assume it's like super small as well, because it doesn't... File size is only 39K. Yeah. Oh. Yeah. Okay, that's working now as well. The LEDs, the built-in LED is now on while the button's pressed and off at other times. Okay. I'm feeling pretty good about this. Yeah. Since we made it this far and we still have about 10 minutes, let's try a shot here and seeing if it will something workable. Do I want to modify this one? I don't want to have to duplicate all of this stuff and use a different build command and everything. What we're going to do is copy that to main basic tone. And then say... So GPIO 1 through and we don't have a 0, but we would theoretically use... Actually, how does the phone work? The 0 is at the bottom, but the 1 is at the top? Is that true? I can't even imagine a dial pad now. It is. That feels so unnatural now that I'm thinking about it. The 0 is at the bottom, even though the 1 is at the top? Who designed this? Okay. To read from, let's just say all 12 macro pad. Well, let's say from 10 of the macro pad buttons. And have each one make a different tone. To make it behave like a dial pad makes phone dialing tones. IO pin 1 through 9 can match with phone number buttons 1 through 9 and use IO 11 for phone button 0. This is definitely off the trail a bit, but I'm curious if it will knock it out correctly or not. And I think it's a fun thing that only takes a minute. Huh? Did I leave a pin mode high thing? Maybe comment it out or something? Oh, shoot. It's maybe not updated. Yeah, I think it was not updated. The thing that does annoy me a little bit is the way this ends up being all broken. But I don't have a good solution. So. Yeah, so basically it did not have the latest code from my editor here. The cloud code here is running on a Raspberry Pi, and I have it linked to where I can see the code on the Pi, and I can copy stuff to it, and I can copy stuff off of it, but it's not like in sync with the code that's here. This code lives on my PC, so I was changing it here, we made the buttons and everything work, using the advice that the other Claude session gave us. But I did it on my PC. I did not do it in the code that is on the Pi. DTMF dial tones will require generating 2 tones simultaneously. That's good to know. Each one is a pair. I didn't know that actually. Yeah, it'll be interesting to see if it does it. It called them DTMF buttons, so it knows we're headed in that direction. Yeah, we can let it do the build since it's fairly quick, hopefully. But then I will copy it back and rebuild it on mine as well. Totally. Here, let me, since these look the same. There is, like a wobble or something. There's like a repeating tick thing going on. I don't know if that's supposed to be doing that or that's just an artifact, but yeah, totally is working for generating the two of those. Or the 10 of those, I should say. Each one being 2, it sounds like. Cool. Let me turn this back down. Sounds like it got it right. Nice. Yeah, the true test would be like audio into the computer and then old school phone listening to the output and see if we could actually dial from it. That'd be kind of fun. I don't have a phone that dials that way, I don't think. Well, probably have a phone, but I don't have a hookup for it that would actually work, I think. Okay. That is cool. I think that is a good stopping point. That's pretty great, Tim. The warble glitching, it sounds like a little audio buffer not getting filled or something. Okay, yeah, maybe that we would need to tweak the size of the buffer or the timing or something in here. Fix that. But yeah, I'm pretty happy with that. That's cool. All right, so I think that is going to do it for today. So I will back to the browser, back to the Adafruit site. I think actually I'm not sure about. Oh, okay. So I'm not sure about JPs, but I think, yeah. So I think JP should be up later today with another product pick. If you would like to not only support Adafruit and this open source software that they support, but also get yourself a nice discount on whatever the special product of the week is, you can do that later on today here on the Adafruit channel, 4 p.m. Eastern, 1 p.m. Pacific during JP's product pick. As always, thanks to Adafruit. Thanks to everyone watching. I will be back on Friday for the deep dive at the normal time there on Friday, which is 2 p.m. Pacific, 5 p.m. Eastern, 4 p.m. Central. And if memory serves, I think this is the last deep dive that I'm covering, and then maybe Scott's planning on being back afterwards, but I'm not 100% sure on that, so don't quote me on it. But definitely I'll be back this week then. I'll be back next Tuesday as well here on my stream, 10 a.m. Central Time on the Adafruit channel. As always, thanks for watching. I hope you all have a wonderful day. So long, farewell, and I will see you next time.